Sir, good morning, sir.
Yeah.
Okay, sir. Okay, sir. Shall we start the session, sir?
Yeah, you can start.
Okay, sir. Okay. Good morning to all. We are going to start the day 5 morning session. The speaker for this session is Dr. V. Vasu. He is working as a professor in Mechanical Engineering Department in NITWarangal. If you see the brief highlighting points of the speaker is Sir has completed PhD in 2010 in JNTU Hyderabad in the field of nanotechnology and nanofluids. Sar also completed postdoc in 2013 in Polytechnic di Milan, Italy, Europe. If you see the areas of research of this are nanocomposites, micro and nano manufacturing process, mechatronics, cyber physical systems, IoT and 3D printing. SAR has published up to now 85 papers in different international journals, national journals, international conference, national conference and book chapters. Sir on his name has some awards like Young Scientist Award in year 2010 given by Government of AP and Institute of Engineers. Sar also was given in 2016 Outstanding Researcher Award in a Nanotechnology Awards from Venus International Foundation. Sar has up to now published two patents. One patent has got granted and another one is filed. Dr. V. Vasu sir has guided up to 50 MTech students and 5 ongoing projects. He has also successfully completed 8 PhD projects and 4 PhD projects are going on. About the details of research projects related to Dr. V. Vasu, Dr. V. Vasu sir has completed research project of worth 150 lakhs funded from DST, UGC, CSIR agencies. Recently received 45 lakhs ASIN project on Industry 4 in collaboration with NUS, Singapore, Malaysian University, Malaysia. He is one of the executive member and lab in charge for mechatronics and smart manufacturing in Siemens Center for Excellence established in NITWarangal with a worth of rupees 2000 crores. Now, this is a deep profile of the sir. Now, I warm welcome the sir to our FDP program to take up the further proceedings. Good morning, sir. Dr. Vasu, sir.
Yeah, good morning, everyone. Yeah, my screen is visible. Yeah,
Yes, sir. Yes, sir.
voice is okay. So, good morning, everyone. The dear participants, thank you for the brief biodata introduction of me. Today, just I want to give you a brief insight on how we can able to implement this particular machine and deep learning algorithms in mechanical engineering point of view. Mainly, what are the some of the case studies what we have implemented at NIT Warangal. Just I will want to showcase some of the projects what my students has been done. Just I want to show some small showcases that one. And before going to that, just I will able to tell you a brief idea on what is this particular machine learning and what is this how we can able to incorporate this in the digital manufacturing. Or just I want to brief you explain you that, and further we can able to go ahead. So if you have any queries or something, you can type in the chat box. Okay, and you once I will complete my lecture, I can able to give you the answers for your thing. Okay, so with this small introduction, just I want to go further. Um, so I want to go. This is why we want to study this particular this artificial intelligence and machine learning. Why? Because the NASCON has implemented these are the some of the important fields. It has been implemented. It has identified these are some of the important areas where the skill development is going to be required for all the people. In that particular point of view, this artificial intelligence and machine learning and this robotics and automation, 3D printing, and virtual reality. These are some of the important areas where we have to focus on, or we have to have skill is going to be required for that one. So with this, just I want to give you one, whenever I want to start any particular my presentation, just I will able to give you have the innovation like that I want to have, because now people are mainly concentrating on this particular aspect of innovation. uh, that is a process of outcome or creating something new, which is always a value worth. That is what the innovation, what the people are mainly focusing on. Okay, so here the main worth means here, if you want to consider this particular innovation, means it should have some value generation should be there. That means it should be able to generate some product, some value. At the same time, it should be an innovative thing in nature. And another thing is it should have to useful for the society. That is the two important things. So how the innovation is going to be incorporated, that is what. So how we can able to achieve is that you can able to start with the technical innovations and customer needs, and some small investment you can able to start for the new products what going to help. Okay, so this is how the concept of innovation has to be there as a manufacturing engineering. So if I want to manufacture any particular product, now this trend of innovation is going to place one of the important role. So that's why just I have kept this slide to start with that one. So as you know that what is the manufacturing? So we are going to be having in the manufacturing point of view, we are having two areas will be there. One is big M, we'll call it, and another is the small m. So in the big M of the manufacturing, so manufacturing is the process for converting ideas and for customer needs into artifacts. That means if you want to make any particular product or something that will include the designs, procurements, okay, finance, everything that will comes under the manufacturing. Whereas in this another small m called as a production, where we'll able to mainly concentrate on how I can able to convert the raw material into a useful product. This is mainly concentrated in the shop floor. So these are the two definitions what we're going to be having for the manufacturing point of view. Okay, so as you see this, this is going to be the closed loop manufacturing process of any particular case. We will start with the raw material extraction from the earth, and we will able to make the material processing and then manufacturing, and then you can able to make the useful product, and then retirement and the disposal what we have. Okay, so but now present manufacturing as a sustainable manufacturing, if you want to have, so then you have to either implement either 6R concept or 3R concept. That is these R's which are going to be shown in the center has to be considered, and these R's now these R's either will be a reduce, remanufacture, reuse, or recover, or recycle, or redesign has to be considered while making any of the manufacturing product. So that is going to be the main concept of the sustainable manufacturing what going to have. So that is a present trend we are mainly following on this one. So from this case, now we are moving into the particular the industry 4 or the digital manufacturing era. So before now present era, we are going to be mainly focusing on this the sustainable manufacturing what we have. So as you see here in the world of manufacturing countries, the China is going to be the highest in case, and next comes the US, and our India is going to be somewhere very less. So if I want to make our Indian as a highest in the manufacturing world, we have to mainly concentrating on this particular manufacturing process what going to have. Okay, so coming to this manufacturing, so we want to know what are the why we want to go for the automation. So if I want to ask for any particular people why we have to go for the automation, so the automation is where we can able to use the different machines to in place of humans what we have. Okay, so for that case, when we have to go for automation and when we have to use the humans has to be one of the biggest tasks. So for that case, we have to know what are the strengths and of humans and machines for that case. So if you see here, the humans, we can able to have the sense unexpected stimuli, develop new solutions, adapt to changes, so learn from experience, and make difficult decisions based on incomplete data. These are all some of the advantages what we're going to be having, humans are having. Whereas the machines have the perform repetitive tasks. If you're having a continuous repetitive task that can be given to the machines, store the large amount of data. They can able to store a large amount of data. At the same time, you can able to retrieve the data, perform multiple tasks simultaneously. That is going to be one of the advantage of these particular machines. So apply high force or high power, we can able to have the high power power also you can able to apply. That is more energy you can able to use. Similarly, perform simple computational quickly, and we can able to use for the routine decision making. The machines are going to be making useful for that one. If you compare these two things, this is going to place one of the important role for the industries. If you consider the difficult, that is to make a difficult decisions, okay, for incomplete data, this is going to be one of the place, one of the important role for the humans. Whatever the data in with insufficient data itself, you can able to make the decisions in a proper way. So that is the advantage of that is sorry. So that is the advantage of the humans what we are having. So at the same time, to cope the abstract of the problem, so we can also have the abstract of the problem, and decision making capability is going to be more for the humans. Okay, so from this I can we can able to tell that the humans have some advantages, and the machines are going to be having some other advantages what going to have. So for that case, we have to go for the automation, which is going to be one of the important in the manufacturing point of view. Okay, so the definition for the automation was given by the International Society of Automation. That is the creation of application of creation application of technology to monitor and control the production and delivery of the products and services. This is going to be the definition what we're going to have. Our automation is the creation of technology and its application in order to control and monitor the production and delivery of various goods and services. This is going to be one more definition the people are mainly using in this the automation definition. We can able to tell that. Okay, so with this, just I can able to show this one small animation. You can able to see here the different trucks are there is no human intervention is not there. So everything is taken care by this particular conveyor belts and AGVs by itself, and they are going to be see here. We can able to the material is going to be uploaded, and loading everything is going to be done. The finishing product also will be done take care by this particular conveyor belt or robots working. That is how the automation is going to place one of the important role. So before going to this particular automation, just I want to give you some historical focus on how this particular manufacturing eras has been incorporated. So when you are going to be considering these manufacturing eras, considering first they are going to be mainly concentrated on the replacement of the muscle power. So as you see that this different animals is going to be are more stronger than the humans. They started taming or domesticating these particular animals like horse or bullocks and donkeys, and these are going to be used for 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 the help of the humans what going to have, because they are having higher strength. So here you can able to see here the muscle power is going to be mainly concentrated on that one. So after the invention of this particular wheel, so now people started using the wheeled locomotives, and by understanding the friction, so where the replacement of the muscle power is going to be replaced by this particular the invention of the wheels what going to have. So after that, the replacement of invention of wheel, we started with the modeling, the mathematical modeling. We have started making the different machines from the invention of wheel is going to be concentrated for this particular machines like our lathe machine or milling machine. What we're going to be having, so all are developed because of this particular invention of wheels. What we're going to have. Okay, so at the same time, we can able to see here mainly the optimization of the manufacturing is going to be done by using the mathematical computing by deriving any particular mathematical models, and we can able to start at that one. So similarly for after that we can able to have the fire inventions. From that the uses of metals in place of rock, some from the rock era to bronze era we have got. So, and finally, we can able to use the wind power, electricity, okay, steam power, and these are some of the important inventions for 20. So that is the energy is going to place one of the important role. So after that, if you see here, the managemental and technical growth as a mechanical engineering or the manufacturing engineering. So what are the different managemental aspects of the technical aspects? What we're going to be having is here you can able to see he's going to be called as the Tyler is going to be called as the father for the scientific management or the industrial engineering, scientific management or industrial engineering. He's going to be called as the father of the scientific management. So he has given some of the important management principles like the division of labor, the incentive schemes, work study, method study. So these are all some of the important aspects has been given by this particular Tyler case. So from these particular principles, now we have started with the concept of mass production, where we can able to use the standards or the tolerances concept is going to be mainly used. So when you are going to be having some tolerances or interchangeability, then you can able to implement a mass production. So mass production means suppose you are having a bolt and nut is there. So this is going to be the bolt and another is going to be the nut. So one person can able to manufacture this particular bolt, another person can able to manufacture this particular nut separately. So because of using this particular the tolerances and interchangeability or the standardization what that is going to be the concept of mass production is going to be implemented there. Similarly, after that, the the work study and motion study is also will be given to increase the efficiency of the particular the manufacturing process has been occurred. Okay, so after this era, so then we are going to be having the line balancing. That is the Ford, the automobile company, the Ford, the Henry Ford has given the line balancing or the assembly lines where the transfer line concept has been implemented, and the total automation is going to be makes a mass production came into existence in the manufacturing plants for going to have. This is some of the examples what I want to have. After that, we are having the hard automation has been started, and then after that, we are having the flexible automation or the soft automation what we're going to have. So previously, we are going to be having hard automation by using the automats and after that we are going to be having flexible automation where we can able to have the CNC and DNC machines or the PLCs are going to place one of the important role where you can able to write your own code in codes. G codes and M codes are going to be given, and that will be given automatically. The automation is going to occur. Okay, this is called flexible automation has been came into picture. So with this, the mass production, the decision, the decision making. Or the interfacing between the departments is going to be incorporated by using the computer integrated. So from that, the concept of the SIM has been came into picture. That is the computer integrated manufacturing, where the computer can able to connect the different departments, and we can able to have the synchronization is going to be occurred. So this is the brief history how the manufacturing has been evolved from starting from the strengthening of the strengthening. After that, we can have uh, what are the different the strengthening. After that, energies, how we can able to different energies levels, and after that, what are the different management principles has been used. Just I want to give you a brief overview so that you can understand this is the present state where we are going to be having. Okay, then so with this we can able to go for the types of automation, as you know, already studied, we are having the three different types of automation. That is a programmable automation, flexible automation, and fixed automation. So depending upon the product variety and depending upon the product quantity, so you have to select which type of automation is going to be useful for your manufacturing industry, what going to have. Okay, so now with this, just I will cope up with when we are to use the robotics and when you want to use for the automation. So if you depending upon the volume, it is depending upon the production volume, you have to select the type of automation has to be selected. So if you are having the volume is very less, don't go for the automation. You use the human labors. Okay, if the volume is lying between V1 and V2, so then you have to use the robots. And if the volume is greater than V2, then you go for the hard automation. What one you have. This is how you have to. The selection of automation has to be done. I think this you know that. Okay. So now coming to this particular era of the digital transformation. So now the present the computer integrated manufacturing is now the mass. Manufacturing is going to be shifting from, because of this particular digital transformation of this particular COVID. This transformation has occurred very fast, as if compared to the earlier stages. So now this mass production is going to be converted into customized production. What going to have? Okay, so that customized production mainly incorporates some of the important concepts of the disruptive industry 4.0 concepts are going to be mainly coming into picture. So these disruptive is everywhere. As you know that the disruption is going to be everywhere. Like you can able to see the Ubers, Ola cabs. Now without any particular, you can able to book your car. Similarly, Swiggy and Zomato, this Tesla, these are all some of the important, and Amazon online shopping. So these are all some of the disruptive technologies which has been arrived from the digital transmission. And now how we can able to incorporate this digital transmission or the digital this disruptive technologies into the manufacturing point of view. So that is going to be the main concept of this particular the digital manufacturing what we have. Okay, just 1 minute. So this is how the the disruptive technologies how we can able to use in the manufacturing point of view. That is the main concept what we are mainly focusing on that. So these are these are some of the disruptive technologies what we're going to be having is the renewable energy, advanced materials, 3D printing, energy storages, next level genetics, and mobile automation, Internet of Things, cloud technologies. So autonomous mobiles and robots. These are some of the 12 destructive technologies has been identified, and these destructive technologies are implemented in different business models of different areas. Now, how we can able to incorporate these different technologies in the manufacturing point of view, so that we can also incorporate a digital manufacturing point of view. That is the main concept of the digital manufacturing what we have. Okay, so just I will pause here. If you have any queries, you can able to ask me, or you can post me. Are you with me? Are you understanding?
Participants, are you having any doubts? You can ask them.
Yeah, are you with me? You are with me, or okay, you are getting
You can
something.
send your doubts in chat box also.
Yeah. Okay.
Participants, if you are having any doubts, you can ask.
Okay.
Okay,
So
sir, you continue.
okay. Okay. So then we will go further. So as uh, how we can able to go further into this particular destructive technologies. The fun important thing which we can uh, we can go here is the internet of internet. So
Sir, there is one question in chat box, sir.
tell me.
What is the 6R concept in manufacturing process in short explanation?
Mm.
What?
So that is how we can able to reuse the materials. So how we can able to reuse the materials, as we have seen that the manufacturing point of view, how we can able to reuse this particular thing. So we cannot able to extract always the material from the earth source. So some of the things we can able to reuse, and you can able to make the reuse of the concept. That is the main concept of the six R's. That is, either you have to reuse the material, or you have to recover or recycle it, or redesign or reduce or remanufacture. These are the things you can able to use that one. That is the six R concept. Okay, clear? Yeah. So then, going further, so one of the important point where we want to go for the digital manufacturing is the internet. As we have seen this particular, because of this particular internet, which is going to be plays one of the vital role. Uh, Another thing, as you see this particular the age of manufacturing growing, so we will start with the manufacturing, that is a mass manufacturing, that is a mass production, where the concept of tolerances and interchangeability is going to be mainly incorporated, and the limits and fits are going to be placed one of the important role in this particular age. Now after that, we have gone to the age of distribution, that is global connectivity, because of the internet, or this Walmart is going to place one of the important role, where we have different franchises in all throughout the thing. And next, the age of information, where we can able to have the connectivity, or the internet is going to be placed here. The information can be shared, like your Amazon or e-business comes into picture. So now present stage, we are going to be in the age of customization. Okay, so from this particular mass manufacturing to customized manufacturing is going to place the important thing. So now we are going to be going in an era of from mass production to mass customization. So what is this particular mass customization means? If you see here this small video, what I want to play. So here you can have previously, when we are going to be having the shoe manufacturing company, if you want to see here, I can able to have either a 5 size, 6 size, 7 or 8 size only. If my foot is not having the size of some 5.5, I cannot able to get the exact size. So either I have to cope up with either I have to either have to start with satisfied with 5 or 6. So I cannot able to get the exact size. So if I want to get according to my foot size, if I'm able to get my size, then that is going to be called as customized product, what I'm going to have. So because of this particular digitalization, now we can able to get our customized product. This is going to be one small video which will able to show you how I can able to get the sorry, how I can able to get my customized product by scanning the foot of your feet. At the same time, this scanned CAD model is going to be sent to the company, and the company, according to your the foot shape, wherever any particular stress points are going to be there. Suppose because of when you wear a new shoe or something, because of stress points, some hurting is going to be occurring on your leg. So that stress points also can be eliminated by using this particular the digitalization what we have. That is one of the advantage where we can able to see. So just I will play the video. You can able to see. Here I can able to scan my foot. I according to that particular, I can able to get the CAD model. This is the CAD model. So once I got the CAD model, I can able to modify the stress points of this particular. I can able to get the stress points. So here, if you see here, some the red color points are going to be called as the stress points, and correspondingly, I can able to modify the design of the shoe by eliminating the stress points. So here I can, these are some of stress points are there. I can able to modify that particular stress point so that I can able to get a customized shoe for myself. So this is what called as the mass custom from the mass customization what we're going to have. Okay, so from now we are shifting from mass production to mass customization. So previously we are going to be having a standard size or things are there. Now I can able to get my customized product. I can able to get. So that can be achieved by using this particular digital manufacturing, the concept what we're going to be having. Okay, so with this, just I will able to give you what are the different evolutions of the industry case what we're going to have. So what are the different sorry. Okay, so this is the industry era. So is my screen visible properly? Yeah.
Yes, sir. Yes, sir.
Yeah, good. Okay. So this is the some of the industry evolutions what we're going to be having. The first evolution where we are mainly concentrating on the steam power, the power energy. Then next we are going to be using the principles of the mass production. That is the line balancing, which are going to be mainly used by the Ford company. And in the third evolution, we are mainly focusing on the computer integrated manufacturing, where the computers are going to be used, and we are going to be using this person is going to be using the G codes and M codes, and finally the machines are going to be coming. And in this particular, the present evolution, the industry 4.0 evolution, we are mainly concentrating on the artificial intelligence concepts what one here. So mainly we are concentrating on artificial intelligence and how I can able to get the information. The information will be called as a big data, and how I can able to have the connectivity, and how I can able to use the cloud computing case what one have. So this is the main concept of the industry 4.0, where we can able to use the artificial intelligence is going to place one of the important role. So this artificial intelligence is not a new word. It is already present in the industry evolution 3 also. So, but what is the main drawback at this particular stage is we are not having a computers which we can able to, which we are not having that much high computers where this computational power can be achieved. So now previously at the same time, as this mainly this artificial intelligence will works on the data, that is all the machine learning or the deep learning algorithms which we are going to be having is are the data driven algorithms what we have. So you need a lot of data. So once you got the data, I want to store that particular data. Okay, in that particular storage is going to be one of the important problem. So now I cannot able to store the data in my laptop. Maximum I can able to go for at that time it will be of some 110 GB is going to be the highest RAM size I can able to have. So now I can able to have a RAM size of in terabytes like that. And if you go for the cloud computing, cloud storage, I can able to go n number of data what we're going to have. That is a disadvantage now presently we're having. So another important thing is the connectivity. So I cannot able to connect one machine to another machine. So suppose here you can see here this robot and these two robots are not connected. So the connectivity issue is also another important problem we are going to be having. So these three important problems are going to be solved in this particular age. Now we have some strong clouds are there like Azure and Amazon, AWS. So we can able to have the storage data. I can able to store n number of data. I can able to store at the same time. I can able to retrieve the data. That problem has been solved. At the same time, now I can able to handle this particular big data, and where the computational power also now in place of CPUs, I can able to get a GPUs are there. So where I can able to go for high computing, also I can able to go further. So that is another important advantage what one have, and I can able to have the connectivity also I can able to do by using the internet, by using this particular IoT concepts what one have. So because of these particular things, now I can able to happily implement this particular artificial intelligence on this particular manufacturing era what we have. So though this artificial intelligence is not new, but because of our drawbacks of the handling of data, storage of data, and connectivity, we are not able to implement this particular artificial intelligence in the manufacturing point of view. Okay, so that is how in this particular industry 4.0, now mainly we are going to be using the artificial intelligence on the big data, IoT, and cloud computing. These are three important technologies are going to be required for this particular the digital manufacturing era. Okay, so as you see here, the computational power of the computers has been continuously increasing. So, but you see here now presently the people are using the computational power of is using in 2015 the whatever the GPUs or CPUs are developed, having the computational power of a rat, the brain. That means whatever the computers now we have designed is equal to the brain of the rat. And in future we will see that it may go up to the brain of the human, and it may be surpassed to the brain of the human also. It can able to go ahead. Okay, so this is the computational power of the computers. If you see here in 2011 onwards, we can have the GPUs are existing there. Before that we are not having that much high computers are not there. That's why we are not able to implement these AI cannot be implemented at one. Okay, so this is one thing. Another thing is this big data. So now we are getting this data. If I want to implement this particular AI, which is going to be data driven, I will able to get a lot of data. So we are having the big data thing where we will considering 8 V's. So like volume. So how much big volume of data we are going to be coming. Value is the particular data is useful value. What is the value of the particular is suppose if you take any particular sensor data, some of the data will be noise data also coming. So how much useful data I'm going to be getting. Veracity, that is dealing with the information, how much information or disinformation I'm going to be getting. Visualization, can you make sense or at a glance, or does you trigger or decision? So how I can able to visualize the particular data. From the visualization data, how I can able to take the decision or not, that will be triggered. Variant, so this is going to be variant means it can have different type of variety of data. It can be the video, picture, or word file, PDF file, okay, MP3 file, any of the variety you can able to have. Velocity means how fast the data can be communicated. Okay, and viscosity means does it state with does it take any particular action. So the data, depending upon the data, we can able to go for a decision can be taken, or some more information is required. That is going to be called the viscosity. And the virality means how we can able to present in a graphical manner. So now we are having the concept of the dashboards are coming. So the virality means how quickly the data can be presented. So these 8 V's of data is going to be called as the big data. So this handling of this particular data is going to be one of the biggest problem. If you handle this data, then AI algorithms can be implemented. Suppose, for example, if you see here, if I want to have an autonomous car like Tesla, it will able to use the sensors like radar, camera, sonic, and GPS and this one. So what the amount of data it is generating per second, if you see here, it will be generating 10 to 100 kilobytes. So per day, if I want to run a particular autonomous car, it is generating a 4 TB of data per day. Suppose if I want to daily continuously means this much of data it has to store, and automatically if this much handling of this particular data is going to be a big problem. Now that problem has been solved by using this particular cloud thing. That is the main aspect. So next important thing is the connectivity. How I can able to connect everything. So that is IoT. That is called as IoT. That is Internet of Things. That is how I can able to use internet to connect all the people. So here you can able to see that things may be anything. Okay, the things may be anything, either human, object, or anything. Previously, you're going to be having this LAN WAN by wire connections are there. Now I want to have the wireless connections are going to be important thing. So by using this particular Internet of Things, I can able to connect all the things. Okay, so this plays one of the important role, and this Internet of Things, how I can able to connect intelligently all the physical systems to gain the definition. The definition of IoT is going to be given. You can able to see that. That is another important thing. Is the connectivity plays another important role. Okay, and coming this particular thing, the cloud computing architecture. If you see here, we are having some different servers are there. We are having different servers, virtual desktops, software platforms, applications, and storage data. These are some of the important things. As you know that cloud computing, we are having three important things are there: ASS, SaaS, like that, application as a service, software as a service. Okay, so that is things which are going to be there, which we can able to incorporate. So here I can able to, the main advantage of this particular cloud computing is I can able to have my own virtual system. I can able to take depending upon the application what one have. So suppose for my application I need a RAM of some 100 TB RAM is required. I can able to select I want a processor storage space of some other thing, and I need these are the softwares. I can able to select that particular computer from this particular computing, and I can able to connect through internet, and I can able to run the program what one have. That is another important concept of this particular cloud computing is going to place one of the important thing. Okay, so just I will pause here. If you have any queries, you can able to ask me up to now. So now you got the concept of why we are these AI is going to be mainly incorporated in this particular industry 4.0. So to implement this AI, I need these three things. So big data, internet, IoT, and cloud computing. Without these three things, I cannot able to implement this artificial intelligence in the manufacturing plants 4.0. Okay, is clear? Any
Participants, are you having any doubts?
if you have any doubts, just you type in the chat box. Are you with me? No? Okay.
No. Okay, sir. You can continue, sir.
Yeah. So then we can able to go further. So now we'll able to see what is an AI. I think already you have already 3 days sessions are over. I think you have learned what is the definition of AI and what is machine learning, everything. Just for your point of time, just I will able to give you what is an AI. AI is a reproduction of human reasoning. We can able to call as human reasoning and intelligent behavior by computing methods. This is going to be called as an AI. By using the computing power, how I can make any particular machine. So here I can able to consider as an agent here. The agent will able to take the information from the, by using sensors, it can able to predict the information from that, and it can able to perform the action on the environmental what won't have. That is how if I want to make this particular agent equal to thinking power equal to the humans by using the computational methods, how I can able to do that, that is going to be called as the AI case, what we're going to be called. So here, just if you want to see here, the The what is just I want to, if you want to understand in the perspective here in the human perspective, what is an artificial intelligence? So can anyone read this particular message what I have shown you? Can anyone read? Just
Participants, please respond, Amma.
can you read it?
Participants,
They can unmute or not?
they can unmute, sir.
Yeah, okay. Yeah. So you can read it now. So if you see here, though it was written in a lot of spelling mistakes are there, but you can able to uh, cannot unmute, sir. So they cannot unmute it. I think so. The settings has been changed.
Change it, sir. The participants, you can unmute and talk.
Yes, sir. Yes, sir. Now it is possible, sir.
Yes.
Yeah. So you can read it now. Yeah.
Yes, sir.
Yeah, you can read it, because how you can able to read it, because of the artificial intelligence you have gained from your birth onwards, because
Okay.
you have gained this particular artificial intelligence. Though I have written something different spelling mistake, you can able to correct, your brain will able to correct itself automatically.
Yes, sir.
So that you can able to do it because of you, because of this advantage.
AI.
That is called as the definition of artificial intelligence. Okay. So yeah. So just you can unmute all. Mute all. Okay. Mute all.
Okay, sir.
Yeah. Okay. So then this is how.
Okay, sir, you can continue, sir.
Sir, it is difficult to
Yeah,
read
yeah.
as it is, but we can read it.
Yeah.
According to a research at Cambridge University, it doesn't
Yeah,
matter
yeah.
in what order the letters.
Yeah. Okay. So that is
Letters not in
this
proper order.
this is called the intelligence you have achieved. Okay, that is because of the artificial intelligence you have to achieve. So now you have to make a machine can able to read this particular thing. So then because of from starting from your
Words
LKG.
not are in proper order.
Hello, are you hearing my voice?
Yes, sir, you continue, sir. Continue, sir.
Yeah. So this is called the intelligence, and we are having the three things are there. We are having the machine learning and the deep learning. The concepts I don't want to discuss more onto this. Just we can able to see here the machine learning. We will need a lot of data is going to be needed. That data is going to be first trained the model according to that particular the neural network model, as your brain is also having a network of neurons. Same we are going to be having the neural network model also will have some neurons will be there. Depending upon this neurons model, you will able to give a particular data will be given, and you will train this particular neuron model, and from that particular model you can use that particular model on the real applications, and this model can able to predict the exact once the model has been trained, it can able to predict that particular thing. So here you can able to see here the icon. Once the model has been trained, it can able to predict it is a dog or cat. That is how the machine learning algorithms are going to be working. In that we are having some two things are there: supervisor learning and supervisor learning. The supervisor learning mainly used for classification and regression. Unsupervised learning is mainly used for dimensional reduction and clustering. Okay, and we are having another one is the reinforcement learning. So this is mainly used for the robotics. So for our mechanical engineering point of view, the robotics, the robots which are won't have, suppose like your the Land Rover, or like your Chandrayaan machine which has gone for the moon. There the robot has to learn itself the surface. Okay, because we don't know what is there in the exact surface. So in that case, that type of learning is going to be done by using this particular the reinforcement learning. So that is the three important the intelligence what we are going to have. So that I did not want to discuss more about on this. I think you have studied just be depending skipping further. Now what is the present status of this particular manufacturing? So here you can able to see the manufacturing point of view, the current extent, we have the intelligence like the assistance intelligence. Okay, we have the assistance intelligence, then augmented intelligence. So now we can able to have augmented intelligence, and now presently we are going to the autonomous intelligence. That means it can able to take its own decision. Okay, so that is the present trend of the manufacturing we are going to be going. So presently we are in this particular stage where we want to augment the manufacturing system. So to get that particular thing, these are the some of the digital manufacturing is also will be called as the industry 4.0. The German people are going to be called as industry 4.0, whereas we are called as digital manufacturing. So these are nine pillars which are the technologies which are going to be required. We can tell that these nine are required, but depending upon your manufacturing plant, some of the things are required. Some of the nine pillars we can remove some of the pillars also. Okay, so like the simulation and the Internet of Things. This is already explained. Internet of Things, the cyber security, then cloud computing, at additive manufacturing, the supply chain management, the big data analytics, autonomous robots, and the simulation and augmented reality. This is going to be another important thing now. VR and AR. This augmented reality also coming into picture where you can able to train the different people without having any assistance. That is the advantage what we're going to have. So these are some of the building blocks what we're going to have. Just I will able to explain you what is a traditional automation with respect to one steel manufacturing plant, and how this particular digital manufacturing is going to be incorporated in this particular the traditional manufacturing what we're going to have. If you see here any particular steel manufacturing plant, you need the raw material. So like iron ore, coal, limestone, these are three raw materials which are going to be required. These raw materials are going to be kept in this particular blast furnace, and this blast furnace is going to be maintained at different temperatures at different levels. So we are going to maintain the different temperatures at different levels. Okay, and once the furnace depending upon the addition of the carbon content, we will able to get the different grades of steels are going to be coming. So once you got the steel blocks will be made either in the form of a block form, either will be in the block form, the rectangular block, or in the form of a rod form, or in the form of a sheet form. So these are the main things which you are going to be getting from the steel manufacturing what we have. So these rods, you know that for construction purpose, we are going to be using the rods. These sheets are mainly used for the automobile industry. If I want to make any particular car manufacturing, I need these sheets. If I want to have further manufacturing is going to be required, then I need this block, rectangular blocks are required. So that will can be done by using this particular the cold mills or hot mills are going to be there. So these are the important the steps which are going to be involved in this particular the steel manufacturing what we have. So now I want to implement the automation in this particular steel manufacturing plant. Then I need these are some of the steps which are going to be required. I need some sensors are going to be required. I need some PLCs are going to be required for controlling. I need the SCADA and HMI, that is human machine interfacing, or the supervisory controller for data acquisition system. I need the MIS system, that is the manufacturing execution system, and I need the ERP, that is material entrepreneur or resource planning is going to be required. So these are some of the important three pillars, or it is going to be called as a pyramid structure of automation, or the traditional automation which is going to be required. So these sensors and actuators are mainly used here suppose here, depending upon the temperature management, suppose I want to have the grade A, grade B steels. So then I want to add the coke has to be added, and the ratio of the iron ore and the coke and the limestone will be different ratios will be there. To get the grade A, the combination will be some 70% iron and 20% of this and 30% of the some 5% of lime, like that. To get some grade B, I need some other things. So that combination of selection is going to be done by using the different sensors. At the same time, I want to maintain the blast furnace at different temperatures. That also can be done by using sensors what going to help. Okay, so that for that case, I need a different sensors are going to be required, and these PLCs are the programmable logic controllers are mainly used to control this particular the total overall the processes what we're going to be having. Okay, so here if you consider the controllers, if you're considering any particular controllers, if you want to consider any particular controllers, we are going to be having the three different types of controllers are mainly used in any particular industry. One is the process controllers. Another is we are going to be using is another is the uh, the the machine controllers are what we're going to be called as the Siemens the CNC controllers what we're going to have. So if I want to make any particular CNC machine run, then we need some the machine controllers are going to be required. Okay. Similarly, if I want to open only for general the basic operation, general operations I want to have, then I need these PLCs are going to be mainly used. So here, if I want to see here, okay, so the controllers like PLCs, 1 minute just. So here the controllers are mainly the PLCs, process controllers, that is the PID controllers, and then your CNC controllers. Okay, these are the three important types of controllers are mainly used here. So these PLCs are mainly used for the general operations like the depending upon the sensor data, the opening and closing of this particular things, everything, the conveyor belt movement, the opening and closing of this particular gates, everything will be controlled by this the PLCs things what we do. Whereas I need the process controllers where if I want to have any particular chemical process is involved, that is the change of state is going to be occurring. Suppose I have started with iron ore, iron that is the solid and coke this one, and I have made the process here, the chemical process where it is going to be melted, the solid has converted into some liquid state, okay, or the liquid to gaseous state, something some chemical change or the change of state is going to be occur. If I want to control that particular process or some chemical reaction, I need this particular process controllers like PID controllers are going to be needed. Okay, whereas here once the material has been came here, I want to make either a rod shape or a rectangular shape or a sheet shape by using this particular millers. So to run this particular millers, I need some machines are going to be required. There's some CNC machines what going to have. So to to control these machines, I need some CNC controllers are going to be required. Okay, so that is the main three controllers are which are going to be required depending upon the sensing activity what we are going to be using here, where we are going to be using the three controllers are mainly used here. Okay, so that is the case with this particular. Once we have the sensors, we have the controllers, then we are having a supervisory controller and the data acquisition what we are required, because as you see here we are having three different controllers are there. To maintain these three controllers synchronization, I need one supervisory controller is required. Okay, that is going to be called as SCADA, the data acquisition. and similarly this HMI is like your touch screens where I can able to write or communicate with the programming for that one. Okay, so once you got that one, above this particular supervisory controller, then we are having the MES system, that is manufacturing execution system, which will able to give you either the production planning, okay, how much material is required, which machine is going to be given, if any particular machine is going to be shut down, then which machine is going to be available. That all will be the planning, the PP, the production planning and control is going to be done in this particular MES system what going to have. Okay, and then comes the next one is the ERP, that is entrepreneurial resource planning, where we can able to make the depending upon the production requirements, you can able to make the raw material ordering. You can able to do here in this particular ERP. It takes what going to have. Okay, so this is how the traditional automation is going to be implemented in any particular the steel plant. I have given the steel plant. This can also be implemented in your the pharmaceutical drug industry. Like also we can able to have this type of thing is going to be implemented in your in your cement manufacturing industry, like that. Okay, so these are some of the some of the traditional automation, the process what the steps which are going to be involved there. So now I want to go from this particular traditional automation to the digital automation or the smart manufacturing, where I want to use this particular where I want to use this particular IT knowledge. Okay, so that I can able to incorporate this artificial intelligence into this. Okay, so that I want to interface this artificial intelligence into this particular manufacturing point of view. So here, whatever the softwares which are going to be used in this particular the range of this is going to be called as the OT softwares. That is operational softwares is going to be called. Okay, so whereas the cloud computing or whatever the IoT thing or your these all considered as the IT softwares what we have. So now I want to incorporate or I want to integrate this OT and IT. How I can able to incorporate this OT and IT? If I will able to do that, then that is going to be called as a digital manufacturing or the industry 4 or the smart manufacturing what we're going to be called. So that I can able to through MES system I can able to connect this particular OT to the IT softwares what we have. Okay, so this MES and how I can able to have the connectivity I can able to achieve by using this IoT and the data driven algorithms, everything I can able to do by using the cloud computing, where the storage of data can be done. Okay, this is the concept of the smart manufacturing, is how I can able to connect this particular IT to OT softwares through internet. So this will able to give you the brief idea. The traditional automation, this is the OT software, the pyramid shape. It will able to connect through Internet of Things through the different clouds server, where I can able to send the sensor data to this particular cloud through Internet of Things, and in this particular cloud, I will have to return different the machine learning algorithms are going to be written, and that will be executed in the cloud itself. And depending upon the information of the data coming from different streams from the data, these AI algorithms will be able to work in the cloud itself, and automatically it can able to take the different decisions like different decisions like monitoring, management, execution. Also, we can able to do in this particular cases for have. That is how the cloud computing. Okay, so in our NITWarangal, we have one small the Siemens Center of Excellence is there, where we have implemented these particular smart manufacturing systems what we have by considering the 13 labs. Okay, so here we are having the different levels. This is going to be the three levels of the traditional automation, like the field level or sensors level, controllers level, MES level, and entrepreneur level. And we have yeah, the Siemens MindSphere is going to be one cloud is there, its own cloud for the Siemens, like Azure by the Microsoft and Amazon, AWS, like that. The Siemens also have one separate cloud called the MindSphere cloud. So through that particular cloud, we can able to connect all these particular sensors through IoT, and I can able to run this particular the software systems what we have. That is how we have implemented in our NITWarangal, how the smart manufacturing has been implemented by using this particular the 13 labs what we have. We are having 13 labs we are having. So just I will pause here. If you have any queries, you can able to participants can can ask questions.
Good afternoon, sir.
Yeah.
Am I audible to you, sir?
Yes, sir.
Yeah.
Yes, sir.
Sir, I'm Dr. Subodh Kumar from SR University, Warangal.
Yeah.
Sir, thank you for giving me this advanced topic on the use of artificial intelligence on this manufacturing system.
Yeah.
Sir, what kind of new things will come in Industry 5.0 when we are going to implement?
Yeah. So that industry 5.0 is the human machine interfacing. Now presently, now the human and machine are not doing continuously, combinedly. Okay.
Okay, sir.
That,
Yes, sir.
that will comes in the industry 5.0. But now presently the stage of first you understand what is the industry 4.0. How we can able to incorporate the artificial intelligence and how you can able to connect the data from the by using the IoT. Once you got the concept of these two things, the next in the industry 5 means how the one half of the, suppose we are having in a particular manufacturing, you have three processes are there. The first two processes are going to be done by the machine, and the third process is going to be done by the human. Or the first process is going to be done by the machine, the second process is combinedly done by the human and the robot, and the fourth process is going to be done by the robot. Like that we can able to share the work between the machines and the human. That is going to be called as the industry 5.0. Okay.
Okay, sir. Thank you, sir. Thank you very much.
Yeah. Any other questions?
Participants, you can ask if you are having any doubts.
Up to now you
Hello.
got it. Yeah. Tell me.
Okay.
Hello.
Okay, sir. Continue, sir.
Yeah. Sir, my question is, see, really, how, the industry 4.0 is implemented in industry in India, and what is the gap compared to the other, the developed countries? And next question is, since this is, ML in mechanical, MLM, the FDP, so one or two case study related to AI application must have been covered. This is my question. That's it, sir.
Now, after another next half an hour, I will show you all the case studies only. How you can able to implement in the manufacturing, everything. I will show you all. The next half an hour is full case studies only. So now
Thank
I have
you.
explained you the concept, everything. So now from this, from next half an hour, I will able to explain only case studies.
One or two. That's it, sir. Yes, sir. Yes, sir. And next,
Yeah.
my question, sir. So, as far as India is concerned, how it is implemented? What % of implementation has taken place as far as Industry 4.0 is concerned?
Yeah. So in India, so mainly these automobiles have already implemented, and now it has started to in the manufacturing plants. It has started. So there is in automobile 90% it has already implemented in automobile industries, manufacturing plants like Tata Motors or the Kia Motors. All these have already implemented, and they are using that one. Whereas like in the steel plants, steel industries, okay, in a small manufacturing plants, this is not implemented. Now they are starting it. Yeah. Any other questions?
Participants, still any doubts you can ask.
So the main important thing, the main drawback in India is all people are working whatever the AL and ML they have people are learned, they are using in the service point of view. So like Swiggy, Zomato, finance, these are all the areas where the service industries like Amazon. Okay, so there are nobody is not interested to implement these AL and ML technologies in the manufacturing point of view. Okay, still they are working for this Google, Facebook, or this Amazon. These are all the service oriented companies. Okay, these are all called as, you can call as a software companies. What we're going to have, how to implement these AL ML algorithms in the software point of view, that there only the people are concentrating. But these Hmm. Hello.
Sir, continue, sir.
Yeah,
Continue.
these ALML were not implemented in the manufacturing point of view, and now I feel that people have to concentrate on these areas, because already that area has been already reached saturation. There is no further scope is not there. Okay, so now I think in next another 5 years, how to this manufacturing point of view you have to think. So because now already in the service area or in the healthcare, so these are the two areas. One is the healthcare and the service area. This ALML is going to be implemented in the other countries. So these are the main areas where they have implemented. In the manufacturing point of view, they have not implemented anything. There is a lot of scope is there to implement in the manufacturing point of view. So these Chinese people are going to be implementing it, but India, any other country are not implementing it. There is a lot of scope. Yeah. Any other questions?
Participants, if you are having any doubts, you can ask participants.
Hello.
Hello. Sir, you continue, sir.
Yeah. So if you have no other doubts, then we can go further. The case studies what I want to have in our NITWarangal. Just I want to show some of the small case studies what we are going to doing it in our NITWarangal. So before going to go for this particular case studies, you should have to learn these three important things. The digital twin, this is going to be the buzzword which we are going to be having. All people are telling that the digital twin what we're going to have. So now we are having the digital twin. Three different types of digital twins are there. So this one is the product digital twin, another is the production digital twin, and the third one is the performance digital twin what we're going to have. Okay, so this product digital twin and this production digital twin already you have seen. Okay, I think you have already seen. Suppose in the product digital twin, suppose you have made one mechanism. Okay, some 4-bar mechanism you want to see, and how this particular mechanism is working. That type of thing we have seen. So that is suppose you have used any particular abacus or some software, you can able to simulate this particular product, how this particular product is working, the mechanisms of the product is working. That is going to be called as a product digital twin. Okay, and next we are having the process, the production digital twin. So suppose in any particular company or in the sim manufacturing people, this type of simulation is going to be already done. Okay, where you have some different AGVs will be there, some different robots will be there, some different conveyor belts will be there, and how this particular material process is going to be occurring, and how you depending upon the process times you have implemented that one. So like you are having a FlexSim, one software is there, FlexSim software, or you are having some of the so many simulation computer integrated manufacturing simulation softwares are there. So there we can able to make the production digital twins. You can able to make it. This is called the production digital twin. So now people are mainly concentrating on the digital twins of performance. Okay, how I can able to get the performance digital twins for that one. Okay, that is going to be called as the exact the digital manufacturing is going to be done. So I want to get the performance digital twin means I will able to get the dashboards like this. So I want to get the dashboards how this particular robot is going to be performing. Okay, what is the performance of this particular robot, what is the performance of this particular conveyor belt, what is the performance of this particular human, everything I will able to get in the form of the dashboards. Okay, if I want to get this particular type of performance digital tool of any particular manufacturing plant, then that is going to be called as the smart manufacturing, or the digital manufacturing what we're going to be getting. So to get this particular performance, the digital twin, you need this IoT, cloud computing, and this artificial intelligence models are going to be required. Okay, to get this particular product digital twin and process digital twin, there is no need for this particular artificial intelligence are not required, or IoT is not required, cloud computing is not required. So this is already you have done in your BTech level, by using any particular CAD software. You have developed the product simulation, and you can able to have some CAM software, so you can able to make the production simulation. So now I want to get a digital twin of in the form of a performance digital twin. So how this particular performance digital twin is going to be required? So there you have to learn this artificial intelligence or data driven algorithms are going to place one of the important, and this IoT plays one of the important role, and this particular cloud computing is going to place one of the important. Okay, where I want to get the process information. Okay, so this is how the example I can able to show you. This is one product is there. Okay, so if I want to get the product same replica in the digital model, a CAD model, if I have developed this particular thing, then that is going to be called as the digital twin of the product. Okay, if I want to identify if I want to get the maintenance history, operation history, real-time operation data, anything, any data is coming from this particular process, then that is going to be called as the digital twin of the production. The digital twin of the production is going to be coming. So this collection of data from this particular real system is going to be done through IoT sensors what we're going to have. Okay, once this particular data is going to be coming in this particular the digital twin product, then by using this particular artificial intelligent algorithms, there is a machine learning or algorithms, optimization algorithms, whatever the data we have got from this particular real system, we will able to apply the cloud computing in this particular artificial algorithms we are going to applying, and then we will able to predict the performance of this particular machine. So like the predictive maintenance, is the machine is going to be repaired, what is the device diagnosis, if any particular device or any particular sensor or any particular equipment is going to be repaired, or how it is going to be occurring, and what are the different design performance improvements. If I want to improve the design thing, how I can able to do that, these are all will comes under the design twin of the performance. This if I want to do, then I need this particular the AI machine learning algorithms is going to be required, which is what we have to do. Okay, so don't confuse with the digital twin of product, digital twin of production, and digital twin of performance what we have. So now you want to get the digital twin of performance of any particular factory, then you need this artificial intelligence algorithms, IoT, and cloud computing is going to be required. Otherwise, there is no need for all this learning what we have. So now people are mainly concentrating on the performance digital twins, where you need this particular AI models are going to be required. Is it clear? Okay, so then we will able to go further. This is how the data driven algorithm for the digital twins of smart manufacturing will be containing different AI models what one have, different levels what one have. So if you consider any particular the levels, you need different connectivity, different levels. We are going to have for storage of data analytics, you need either Spark or Hapido, or you need from connectivity, you can able to go for 5G, 3G, Bluetooth connectivity, or Wi-Fi connectivity. You can able to have different protocols which are going to be required. If I want to have the different apping data, I want to have either I can able to make the different apps. Also, I can able to make the Hadoop app for analysis, the data analysis. If I want to have the big data is there, to get the exact proper data, then I have to use this Hadoop data analysis has to be used. Similarly, once I got this particular data, I want to make the presentation. I want to generate different dashboards in a useful manner. Then for that case, I want to have some different proper app designing is going to be required. So this is the total concept of the data-driven based the smart manufacturing will be able to containing both the combination of OT and IT, the softwares what we have. These all are IT softwares also there, and OT softwares also will be there. So to predict the exact the data what we're going to be getting, some different AL, ML prediction models are going to be required, which will be implemented here. Okay, so this is how the digital twin of the concept of the digital twin performance digital twin of any particular factory is important. Okay, so here in our NITWarangal Siemens Center, we made some different case studies. We have one map system is there supplied by this MTAB, which will contain some 5 stations are there. That is 5 substations are there, starting from the material selection. If the material the size and dimensions are going to be checked in the first station, and that material dimensions and the material is not a plastic material, if it is a metal material, then that will be rejected. Then it will go to the next station where the filling of the material is going to be done, and after that next it will go to the buffer station where the storage of the things is going to be done. Okay, and then you can able to have the sorting station where it will able to sort depending upon the color of the equipment what one have. So this is the equipment what we're having. If I want to get a proper information, if I want to get the proper performance of the thing, so then I need some different we want to use this nano box. This is going to be called as IoT nano box, where the connection is going to be done through this particular connection of IoT nano box we are done, and we are going to be getting the different dashboards are going to be coming like this. So we are going to be getting the different dashboards like this, the distribution center, what is the performance. Okay, this is the performance is 96.6. This is the performance. How the pressure sensor is working. Okay, what is the availability of this particular machine? This is the availability is 15.8% availability. What is the production cycle? There is a runtime, lifetime. What is the downtime? How much downtime the machine is going to be there? Everything I can able to get from this particular in the form of the dashboard. Similarly, I can able to get the overview of the different stations. I told you, we are having the distribution center, test center, processing center, the buffering center like this, and sorting. All machines, the performance dash sheets, I can able to get it in this particular form. If I'm able to get this in a perform, then it is going to be called as the digital twin of the performance of the particular system what we have. So in this particular video, just I will show you that particular map system. You can able to get the data. Sorry. Is the video running?
Yes, sir. Yes, sir.
So these are the 5 stations. The robot will able to pick the particular material here. In the test station, it will test is that particular material is going to be plastic material, or the dimensions are going to be accurate. If it is not dimensions are accurate, it will reject. Otherwise, it will pass to the other station, the processing station. Then the material is going to fill into this particular thing. The material is filled there, and then automatically that will comes to the buffer station. If any two materials are came, then only it will allow for the next station. That is called as a buffer station. And in the sorting station, it will able to sort the material into two levels. Level one, depending upon the color. If it is a red color, red color will go. If it is green color, so you can able to see this in a more deeper manner. So it will testing the testing station. If it is a non-metal, it will go to the further thing. Okay, so in this buffer station, if two items are came, then only it will allow to the next level. Then in the sorting station, it will able to sort depending upon the color. It is a red color means goes to red color, and white color goes to another white color. So here the sorting station. Okay, so this is the five stations what we're going to be having to sort everything. The performance of all the sorting stations, you can able to get it by using this particular the dashboards what I have shown you that. Okay, so this nano box, everything was supplied by the Siemens company, where the cost of this particular equipment is little bit some 5 lakhs 4.5. So what we have done is we have used uh, some open source thing by using this particular Node-RED. Okay, by using this particular Node-RED and Raspberry Pi, instead of this particular the nano box, our students we have developed by using the Node-RED programming and the Raspberry Pi, and collect all the sensor data what we're going to be having, and we have used our own one small the ThinkSpeak cloud system, that is also open source ThinkSpeak cloud system, and there we have deposited all the particular data into the particular and we have developed our own dashboards by using the different dashboard development software, that is open source software, and we have made that one. So this cost very less. Okay, so this is the some of the Node-RED applications what we're going to have. The same thing we will able to done. So this is the open source software, you can able to use the Node-RED also. Just I will able to show this is the dashboard we have developed in our lab. Okay, the performance of the particular thing, how much current it is on or not, we can able to do that. So this video will show you the same operators, how the performance done by using the Node-RED operator.
This is a modular automated production system. At distribution station, the actuator pushes the bottle out and the griper arm moves down to clamp it. Then it goes up. rotates 180 degrees and puts the bottle at next station. At the testing station, the height measuring module measures the height of the bottle, and after that an inducting sensor will inspect for metal or non-metal object. If it passes
So
both the
here
tests,
you can able to
proceed
see in the
next
dashboard
station.
automatically
Otherwise, it
how
will be
many red
rejected by
bottles, how many
rejection
white bottles, how many rejection, everything you can able to
Now,
see
at the
online also
processing station,
in
the
this
rotary
dashboard. That is
indexing
called the
module will
performance.
index the bottle to the filling and capping module. The buffer station controls the process of buffering and optimizing the supply of bottles to sorting station with different process times. The sorting station sorts the bottles by color, and the colors are detected by sensors.
So here you can see the red bottle is one, white bottle also will
White
become
bottles are
one.
stored separately and red bottles separately. All the data related to the production is displayed
So
on the
this
dashboard.
this also all the availability, runtime, everything also calculations also will be shown in this particular downward graph.
Now here we can see how a metallic bottle is sensed by the inductive sensor, and after that rejected by the rejection module, which consists of a pivoted arm deflector. The rejected bottles are stored in slide bed. The rejected bottle data is shown on the dashboard. Also, an alert message is sent on the email ID of the user after the rejection value crosses a preset limit.
So
Now here we can see how the data is represented on the dashboard after 8 bottles have been used by the production system overall.
So this is the same thing was developed by our PhD student and MTech student. Similarly, this is another case study where we want to convert the legacy machines. That is what we're going to have. This is the legacy machine. What we're going to have the lathe machine, which is a very old machine of nearly 25 years old. So I want to convert these legacy machine into an IoT enabled machine. So by using this particular the sensors and IoT sensors and the communication system, we have used the ESP Wi-Fi module. So for that case, for the communication, we have developed inbuilt developed this particular box which will contain the ESP mode, connectivity. So to get the sensor connectivity, this one we have developed our inbuilt box, and from that particular box we can able to send the data to the cloud. Okay, and automatically whatever the machining is going to be occurring here in this particular old machine, I can able to get all the data, everything, and I can able to send it to the cloud, and I can able to get the information in this particular dashboards. What is the performance of this particular, how much power consumption it is doing, if the machine is working, and what type of machine object is it is doing, milling operation or turning operation. Everything information I can able to get it from that particular vintage machines workman here. This is one more example we can able to one more case study we have done, one of our project student has done. Okay, so this is another important the smart thing we have made one CNC milling machine like that. How I can able to convert, we have inbuilt this particular CNC milling machine automated. Instead of milling, it will able to we will able to send the G codes and M codes to this particular milling machine through our mobile, and automatically depending upon the G codes and M codes, that milling is going to be operated. So here we use instead of milling, we are going to be using one small sketch pen has been kept there, and that sketch pen will be able to draw that particular thing. This is another important case study we have done.
Development of a cyber system for controlling a CNC machine. First of all, we'll try to trace a circle on the CNC plotter with CVS framework. Here, on the left-hand side, you can see the GUI which was built extensively for the CBMS framework. The right-hand side consists of two parts. The top right corner shows the server where the G-code gets uploaded once it's sent from the GUI. The bottom right corner shows the CNC plotter which is used for testing the CBMS framework. Here, in the GUI, once you upload the G-code, you can see the streams of the G-code lines which are sent line by line to the CNC plotter via the server. Once you press the send, the G-code of each line is sent to the server, where once you refresh the server, you can see the G code gets uploading there. And the G codes are then passed by the CNC microcontroller, which is an Arduino, consists of GRBL, and the CNC plotter will trace the exact same pattern which the GUI has provided. Here you can see on the right hand side corner, the CNC plotter is tracing the circle for which the G code was given and the constructions were given from the GUI. Next is, we will try to trace a complicated figure on the CNC plotter with the CVMS framework. Here you can see that we gave a G code for printing a hello, and once you press send, the CNC plotter is actually printing the hello, and you can see the GUI is tracing the hello as in the GUI itself. So by doing these experiments, we were able to establish that the remote control CNC machine is quite possible with a cloud server. Perhaps we also tested our server on different networks for different speeds and found a latency of not more than 1 second. So we can definitely conclude that remote control of a CNC machine is quite possible and will open the new doors for the new era of manufacturing.
So this is another small project we have done. All the G codes are going to be sent through the cloud computing through our mobile phone. Okay, this is how the machining. Some of the examples have shown. Some more examples I want to show on this automobile industry. As you know that this particular automobile industry, previously we are going to have a lot of evolution has been occurred from this ambassador in 1975 to now that is Tesla model S model, which is going to be having this much sophisticated thing. So this a lot of innovation has been occurred in this particular industry 4.1 in automobile engineering. So some of the things, so many sensors you can able to see here now present case. So if you see here, participants, is the time is available? Hello.
Yes, sir. Yes, sir. It is available, sir.
Okay, so I will take another 15 minutes, no problem.
Okay, sir. Okay, continue, sir.
Continue. Okay. So in the automobile point of view, we have some different eras are going to be occurring in this particular era. One is the embedment era, and after that informatics era. And now presently we are going to be coming to the V2X era, that is vehicle to X. The vehicle can communicate with the vehicle, another vehicle to another human, vehicle to any infrastructure. This is all called as the vehicle to VX communications 4.0. So this is the levels of automation. In this each level, you can, if I want to drive any particular car, you need 2 hands, 2 legs, 2 eyes, 1 brain is required. So we are having each level of automation, we are removing one by one. So here in this level of 1, we have, there is legs are free, only hands and eyes and brain are useful. So that is going to be called as your cruise control. Okay, and then level 2, the legs and hands are free. Okay, only brain and eyes are going to be there. This is the level 2, and in the level 3, your eyes also will be free. Okay, now presently this Tesla has been implemented this type of automation, the level 3 automation what going to have. So where in the level 4 and level 5, there is no driver, or your brain also will be off. Okay, but still some of the research are going on in this particular level 3 and level 4, but this level 3 cars are already available in our market. So this is going to be the Tesla, whatever we have implemented this type of the level 3 has been implemented what going to have. Okay, so this is the level 3 automation car, the Tesla car, where you can the car can able to drive itself to the different case. This is going to be one small video we can able to see, but the human person has to be available. Okay, he has to check that one. So to get this particular level 3 automation cars, we need, these are 3 important sensors are going to be required. One is the GPS sensor, one is LDR, one is radar, video cameras, and the position estimator. These are 3 these sensors are going to be incorporated in this particular thing, and you have to get that particular information. As you know that the GPS sensor will able to extract the mapping database. What is the mapping database? It is going to require that will able to give the mapping extracts, and this radar will able to determine the position of the obstacle objects what we have, and this radar obstacles is going to be kept in the front and back of the car. And in this LDR is going to be one of the important sensor. It is mainly used called the light detection and ranging sensor, which will able to rotating sensor, which is going to be called as the heart of the automation. It can able to get exact 3D map of the surroundings. It will able to get exact 3D map of the surroundings. You can able to get like this. This is a 3D map. Suppose this is the here you can able to see the exact car is moving, and I am able to get the 3D map of all the surroundings. Which car is going making that one. So this LDR will able to sensor will able to generate this type of 3D map is going to be generated. From this particular 3D map, I can able to predict exactly which type of car is going to be at what distance, everything. So this LDR plays one of the important role in your car automation what going to help. Okay. So next sensor is the video camera sensor. So this will mainly indicates the detection of the traffic lights, okay, or the signals or something, or any particular moving objects also it can able to detect. These are some of the sensors what we're going to have. Okay. So with this particular thing, we can able to go either adapt to cruise control, adapt to light magazine, and traffic light signal recognition. These are some of the important features already available in your market. So adapt to cruise control means here the car is going to be maintained at a proper speed in the highway. Suddenly, if any particular car will comes in the pace, automatically the car will speed will decrease. This is going to be called as adapt to cruise control. Okay, this we can able to already in our Indian cars also it has been implemented. This is called as adapt to cruise control. Whereas this particular another case is the high beam light. So here in this particular high beam light, so when you are going in the night, when you are going in the highways, because of the coming opposite cars light, you cannot able to see your thing. So to eliminate that problem, what the people have done is the high beam light. So whenever any particular car is coming in the LED thing, some the portion where the car is coming that will not glow, so that I can able the person which is coming, this person can able to see the light, the road properly. So this is going to be called as a high beam light technique what we have. This is also you can able to implement in a proper manner by using the AR VR applications what we have. So next is we have done one small project to make our autonomous car by using this particular LDR sensor and the camera sensor. For the autonomous car, we have built this particular small setup there. We have used this particular PI camera, and we have used this particular LDR, and we have made Raspberry Pi programming. And this is the track this car has to make move on this particular track. This is going to be a track what we have, and these are some of the components what we want to have. So the main objective of this thing is it has to identify the line identification, the track exact line identification, obstacle identification, and it has to identify the signs also. If it is a left turn, it has to left turn. If it is a red signal means it has to stop, green signal means go, and if it is a stop signal is there, it has to stop. So that we have to do make this particular autonomous thing. For that case, we have used this is the deep learning algorithm. Deep learning algorithm has been indicated used mainly for this particular line detection. So to form identify this particular line detection, this CNN deep learning algorithm has been modeled for this particular images what we have done. Okay, so this is how the motion we can able to see here. In this case, the line detection is going to be done by the car. So automatically it is able to detect the particular car by using this particular camera, the image. It will able to move. So this is the deep learning CNN deep learning algorithm we have implemented for this case here. Similarly, for identification of the symbols, so it is a stop symbol, we have to go in 30 kilometers per hour, 80 kilometers per hour, left turn, stop. For that case also, we have given another CNN algorithm for this case, and we are going to use this one. So whenever this signal is going to be even automatically, it will be able to turn that particular case. Similarly, if it is a stop signal is going to be there, it will detect that and it can able to stop that one. Okay, so this is the two algorithms we have trained. So for obstacle evidence, we have used this particular LDR sensor. If any particular object is going to be coming into picture, we have kept any particular object. Depending upon the LDR sensor will able to detect and it will able to stop. So when the object is removed, automatically the sensor will able to the object will able to do that. Similarly, if it is having we incorporated three sensors fusion, the camera sensor and LDR sensor. The camera sensor will able to get the images depending upon the line tracking, and the symbols also it can able to detect, and this LDR will able to identify the obstacles what we have. This is one small project which has been done by our students what we have. Okay, so with this just I will stop here. This is one more project was done for conditioning monitoring of the bearing materials. So we have given three faults it can able to do. There is outer race fault, inner ring fault, or ball fault. These are three faults which we can able to get in the ball bearing. So to identify the health monitoring of this particular thing, we have made one deep learning algorithm by converting that particular acceleration signal into as a scaleogram. That is, he's going to be we will convert that particular acceleration vibration signal into an image. So depending upon the vibration, I can able to convert this into different wavelet image, and from that particular wavelet image I can use this particular reset algorithm, and we have predicted and we can able to predict all the faults in this particular bearings what this is another important case study what I want to show you. Okay, so this is how our Siemens Center of Excellence, we have all these particular facilities. If you are free, you can come and visit our case collaboration. Yeah, you can now you are open for you can able to ask me, and you can contact me. This is my email, vasu@nitw.ac.in, and these are some of my PhD students work. What I have presented is all not my work alone. It has been done by my students of PhD or MTech students. Okay, so this is from my side. If you have any queries, you can able to ask me in another 5 minutes.
Participants, you can ask your doubts, Summa.
Sir, other than image processing and data capturing to do the quality analysis, what are the other techniques that is available that we can try using AI in the manufacturing sector?
Whatever means you have so many other sensors are there. Okay, so any sensor you can whatever the sensor data, suppose you are having in the bearing materials, there we have used the vibration data. Okay, whereas in the automobile we have used two different types of sensors. One is LDR sensor and another is we are using the camera. Okay, so depending upon the type of sensor you have selected, you have to select that particular AI model. Okay, what type of data you got and how to feature depending upon the feature recognition. I think you have already studied what is the feature recognition, how we can able to go for that, what is the wavelength, everything. So I don't want to go in detail about the algorithm. So depending upon that feature recognition, you can able to depending upon the sensor data, you can able to select any particular sensor.
Okay.
Yeah.
Thank you, sir.
Any other questions?
Participants, you can ask your doubts, Summa.
Professor Vasu, I think, sir, we have already connected. We have connected for the IEOM conference last year.
Yeah. Okay, madam. Yeah. Okay. So you are from Kerala?
Yes, sir. Yes, yeah. You are remembering.
Okay.
Thank you.
Yeah. Okay. Yeah. Any other questions? Yeah.
Nice session,
If-
sir. Thank you.
Yeah, thank you. If no more questions, then we can, you can, if you have whatever the questions, you can mail me. Then I can able to give you insights. So you can, whenever you are free, whenever you come to NITWarangal, visit our lab, our Siemens Center of Excellence, and I can able to help you out in any other means. You can able to do that. Okay. Okay. Then
Okay.
bye.
Okay, sir. Thank you very much, sir, for accepting our invitation and giving a wonderful lecture. I hope most of the participants got a basic information about digital manufacturing, IoT, AI, and cyber physical systems. Thank you very much, sir, for giving a excellent lecture.
Okay, then bye.
Thank you, sir. Thank you.